Example 1. The following sequence is a combination of geometric and an arithmetic sequence. 7, -7, 21, -14, 63, -21, and so on to infinite terms. Write down the next two terms. Calculate T74 minus T73. What is the sum of the first 50 terms of this sequence? Prove that all the terms of this infinite sequence will be divisible by 7. Solution. If we consider the first, third, fifth terms of the combination sequence, we observe that the terms are in a geometric sequence. The common ratio of the geometric sequence is given by r equals t2 over t1 or r equals tn over tn minus 1. Substituting the values for the first two terms of the geometric sequence, we get r equals 21 over 7 equals 3. Similarly, if we consider the second, fourth, and sixth term of the combination sequence, we get an arithmetic sequence. The common difference of the arithmetic sequence is given by d equals t2 minus t1 equals tn minus tn minus 1. Substituting the values for the first two terms of the arithmetic sequence, we get d equals -14 minus -7 equals -7. The next two terms of the combination sequence are the seventh and the eighth term of the sequence. The seventh term is the fourth term of the geometric sequence. It can be found using the formula for the nth term of a geometric sequence. Tn equals a times r to the power n minus 1. T4 equals 7 times 3 to the power 3 equals 189. Similarly, the eighth term of the original sequence is the fourth term of the arithmetic sequence. This can be found using the general formula for the nth term of an arithmetic sequence. Tn equals a plus n minus 1 times d. T4 equals -28. Therefore, the next two terms of the original sequence are 189 and -28. To calculate the terms T74 and T73, let us find a set of general formulae for the even and the odd number terms of the combination sequence. The even terms form an arithmetic sequence. Therefore, the formula for the general term will be T2n equals a plus n minus 1 times d, where n is any natural number. Here, 2n will be an even number. So, T2n will be an even term, for example T2, T4, etc. Therefore, T74 equals -7 plus 37 minus 1 times -7. The odd number terms can be determined using the formula for the general term of a geometric sequence. T2n minus 1 equals a times r to the power of n minus 1. Again, n is any natural number. Here, 2n minus 1 will be an odd number, so T2n minus 1 will be an odd term, for example T1, T3, etc. Therefore, T73 equals 7 times 3 to the power 37 minus 1. Now, T74 minus T73 equals -259 minus 7 times 3 to the power 36. Consider the first 6 terms of the combination sequence. The sum of this sequence is simply the sum of the first 3 terms of the geometric sequence and the sum of the first 3 terms of the arithmetic sequence. Extending this reasoning to the given problem, the sum of the first 50 terms of the combination sequence can be determined by adding the sum of the first 25 terms of the geometric sequence and the first 25 terms of the arithmetic sequence. Note that the odd numbered terms of the combination sequence are the terms for the geometric sequence, and the even numbered terms are the terms for the arithmetic sequence. Applying the formula for the sum of n terms of a geometric sequence, Sn equals a times r to the power of n minus 1 all over r minus 1. We know that a equals 7, n equals 25, and r equals 3. Substituting the values, we get S25 equals. Now, applying the formula for the sum of n terms of an arithmetic sequence, Sn equals n over 2 times 2a plus n minus 1 times d. We already know that a equals -7, n equals 25, and d equals -7. Substituting the values, we get S25 equals. Adding equations 1 and 2, we get S50 equals 7 times 3 to the power of 25 minus 1 over 2 plus -2,275 We are required to prove that all the terms of the given infinite sequence will be divisible by 7. The even terms of the sequence are given by the formula T2n equals a plus n minus 1 times d, where n is a natural number. Or T2n equals negative 7 minus 7n plus 7 equals negative 7n. Similarly, the odd terms of the infinite sequence are given by T2n minus 1 equals a times r to the power n minus 1, where n is a natural number. Or T2n minus 1 equals 7 times 3 to the power n minus 1. We can observe that the general terms of both the components of the infinite sequence are multiples of 7.
Need more help? Subscribe to our channel. Can't wait that long? Ask Mesky to help you and let the math finally start mathing.